Okay, good morning, everyone. This is O-level paper 2, 505422, and the year May, June 2021, and the time 1 hour 45 minutes. So we'll move to question. It has two sections. Section A, answer all questions in this section, answer in the space provided. Okay. Now, state the difference between the scalar quantity and a vector quantity. So, scalar quantity has no direction. It has magnitude and unit only. But the vector quantity has a direction along with the magnitude and unit. Okay, the next part 2 is state two examples of each type of the quantity: scalar quantity, mass, distance, speed, density, pressure, resistance, voltage, etc. And the vector quantities are displacement, velocity, acceleration, force, momentum, moment. So there are many. Next, the B part is the figure 1.1 shows the direction of the size of the two vectors P and Q. In the space next to figure, draw a label vector diagram to show the resultant vector obtained by adding vector P to vector Q. Draw the vector P and Q and the resultant vector to the same scale as shown in the figure 1.1. So first, you have to measure the length of this vector P. You have to draw a parallel line to this of same length, use the scale. This is the P vector. Now, measure the length of this Q and add this vector in front of this, mean head to tail rule. So this is Q. And then join the tail of the P, mean the tail of the first vector with the head of the last vector, mean Q. So this line is representing the resultant of these two vectors. Now move to the next. A car approaches a set of the traffic light. The lights change to red at time 0. Here it goes red. Figure shows the speed of the car changes with time. The car starts to slow down. A short time later, light goes to changes to red. Determine the time between the light changing to red and the car starting to slow down. So we have to record this time and this time. So this time is 1.2, 1.4. Yes, this is 1.4 second. So mean time for this horizontal line, this one, because the brakes starts at this point. Next is state what is meant by the uniform acceleration. So the change in velocity is same for each interval of time, for each fixed interval of time. Mean in every second, the change in the velocity is constant. In every second, if the velocity is changing uniformly, then this is a uniform acceleration. Next, state how to show that the deceleration of the car between 2 seconds and 7 seconds is non-uniform. At 2 seconds, look at the gradient of the line, and at the 7 second, this is the gradient. So look, acceleration is the gradient of this graph. So the two gradients are different. So acceleration different, mean non-uniform. So at 2 seconds and 7 second, gradient of graph is different. So that's why both acceleration is not uniform, they are non-uniform. Next, determine the distance the car travels from the moment of the car starts to slow down until it stops. So it's slowing down from this point, 1.4. And then this is the first portion in which the gradient is large. And this is a trapezium. And then triangle, mean we have to add this A and B figure area for the total distance. So look, this first A, 1/2, sum of the parallel sides, multiply by height, mean 1/2. One side is 20, and the other parallel side is 8. And the height between these two is, this is 4 minus 1.4. So this is 3.6. Sorry, 2.6. So we have to simplify this. So 1/2 multiply by 28 multiply by 2.6. So this is 14 times 2.6. And now come to this B. It's a triangle, half base into height. So 1/2, its base is 7 minus 4 is 3, and its height is 8. So 1/2 multiply by 3 multiply by 8, 2 ones are 4s are, so this is 12. And after the addition, this 14 multiplied by 2.6. Okay, this answer is coming 36.4 meter, and this is coming 12 meter, and we have to add both. So 36.4 plus 12, it is coming 48.4. So here, 48.4 meters are in two significant figure. We can write 48 meter. So now move to the question number 3. The figure shows a small brick hanging from a Newton meter. The reading on the Newton meter is 3.0. Describe how the reading on the Newton meter is used to find the mass of the block. So Newton meter measures the weight, and weight is equal to mg. So m is equal to w divided by g. Mean 3.0 weight divided by g value 10. We will get the mass in kilogram. Next, the same brick and the Newton meter are used in the operators shown. The meter rule is pivoted at the center, is balanced. The reading on the Newton meter is not shown. So this is the diagram. So this is the pivot. This block is trying to rotate in this direction anti-clockwise, but the force exerted by the Newton meter in this direction clockwise, it is balanced. State the principle of moment of a body in the equilibrium. So we will write in the state of equilibrium, sum of clockwise moments is equal to sum of anti-clockwise moments. So this is the principle of moment. Mean clockwise moments and anti-clockwise moments are equal if the object is in equilibrium. And the next, determine the reading on the Newton meter shown. So we will apply the same rule, clockwise moments, F1 D1 exactly equal to anti-clockwise moments. So F1 D1 is equal to F2 D2. So we attempt it here. F1 D1 is equal to F2 D2. This F1, suppose this one, it is 3 Newton. Its distance from the pivot, 10 plus 20, it's 30. But we have to convert this in meter, divided by 100. And the force of this Newton meter is required. And Newton meter perpendicular distance from the pivot is 20. So 20 divided by 100. Now we can cancel the 100. So it is 90. 30 multiplied by 390 is equal to force F2 multiplied by 20. So 9 divided by 2 means the answer is 4.5 Newton. And we will write here 4.5 and the unit Newton. Next is a beaker of the water is placed so that the brick is partially submerged in the water as shown in the figure. The apparatus is adjusted to keep the rule horizontal. So look at this. Suggest why the reading on the Newton meter is less than your answer, mean less than 4.5. So now the answer for this force is less than 4.5. Reason is due to the water. There is an upthrust exerted, mean the water is exerting upthrust. So at this point, the less force, less than 3 Newton is exerted. Distances are same. So F1 D1, F2 D2. So when this force is small, definitely this will be small because the distances are kept same. So we will write here, water exerts upthrust on the block. So its moment, its turning effect decreases for the equilibrium. Anti-clockwise moment also decreases. Hence, Newton meter force also decreases because its turning effect decreases. Next, the question number 4. The question number 4 is, in a demonstration, a teacher uses a loud ticker clock, 2 hollow tube A and B, a barrier and a smooth surface. The clock is used as a source of the sound. Figure 4.1 shows tube A and the clock both fixed in the position on the left of the barrier. Sound from the ticker clock passes along the tube A and is incident on the smooth surface. A student listens to the sound passing along the tube B, which is on the right of the barrier. Draw the tube B in the position where the sound heard by the student is loudest. Look, the sound is traveling through the tube, A tube. It's striking here. This is the point of incidence. And then this is the normal. This theta is the angle of incidence. According to the rule, angle of reflection is same. So this is the reflection of the sound, same angle theta. It means we have to place this tube B here. And then we will place ear here to hear the loud sound. So the angle of incidence is equal to angle of reflection. This is the logic here. So the question is, explain your answer to this. So we will write angle of incidence is equal to angle of reflection. So for the loud sound, tube B must be placed at the position of reflected sound. Next, the speed of the sound in air is 330 meters per second. State the typical value of the speed of the sound. So you can write any value from 2000 to 8000, suppose 3000, 4005. So 3000, suppose, and meter per second. Next question is question number 5. The figure shows figure 5.1 shows the method of producing sandpaper using a static electricity. So this plate is negatively charged, this plate is positively charged. So the charges are developed due to the friction. Work is done against the friction. Glue is sprayed on the moving paper. The sticky paper then passes between the two metals. One of the plate is positive, other is negative. There is an electric field between the plates. Draw the electric field between the two metal plate. Show the direction of the electric field. Look, this is positive. So all electric field lines are directed from positive to negative due to parallel position. So we have to draw uniform field, mean equally spaced field lines. And then one line from the edge, non-uniform. And the next is the grains of the sand are present just below the sticky paper. Each grain of the sand is a conductor of the electricity. Figure shows 2 layers of the sand grain in the space between the two plates. So here they are shown. Explain using the idea about the movement of the charges. Why the top layer of the sand becomes positively charged. So this layer is positively charged. So substance, the body, becomes positively charged after losing electrons. So these electrons are attracted by the positive plate. This is the reason. This is the logic. So electrons of these sand particles are transferred to positive plate. So loss of electron is the positive charge. So the object which loses electron is the positive charge. So these particles are losing electron because their electrons are attracted by the positive plate. After the loss of the electron, they are converted into positive charge. State why the top layer of the sun moves towards a sticky paper. Okay, so this is the negative and these particles are the positive. So there will be the force of attraction. So the top negative plate and positive sand particles, grains, are attracted due to opposite charges. Because we have done that the like charges repel and opposite charges attract. The next is a student receives an electric shock by walking across a certain type of the carpet and then nearly touching a piece of the earth metal with his hand. The potential difference between the hand and the metal is 2000 volt, and the charge transferred is 4 into 10 power minus 4. Calculate the energy transferred when the spark jumps across the air gap from the metal onto the hand. So first, energy is equal to charge multiplied by voltage. This is a formula because the voltage is equal to work done per unit charge and the work is energy. So energy is equal to charge multiplied by voltage. So charge is 4 into 10 power minus 4 and the voltage is 2000. So the final answer will be 0.80 joule. Next, question number 6 is the power input to a filament lamp when connected to a 12 volt supply is 20. State what is meant by power. Power is work done per unit time is called power. Mean how much work is done in 1 second. That's a power. Calculate the current. Look, power given, voltage given. So we can write formula power is equal to IV. So I is equal to power divided by V. And the power is 20. Voltage is 12. So 20 divided by 12. The answer is 1.7 ampere. Next, the resistance of the filament. So according to Ohm's law, V is equal to IR. R is equal to V over I. And V voltage is 12. Current is calculated 1.7. And after calculation, so the answer is coming 7.058. So we'll write 7.1 and the unit ohm. Next, the filament in another lamp is made from the thinner wire of the same length and made from the same material. So both lamps are connected to 12-volt supply. State and explain how using the thinner wire in the filament affect the power input of the lamp. Look, resistance is inversely proportional to area. Thin wire has small cross-sectional area, mean the large resistance. Due to large resistance, the current decreases and power is equal to IV, voltage same. When the current decreases, power also decreases. Because the power depends on current and voltage. The voltage is constant, so the power directly proportional to current. When the current decreases due to the large resistance, then definitely the power also decreases. Next, question number 7. Figure 7.1 shows part of the simple DC electric motor. The motor is connected to a battery with the positive terminal of the battery connected to the terminal A, meaning the current is moving in this direction. Explain why the coil turns in the direction shown. So first we have to write the current flows from positive to negative. And number 2, according to the Fleming left-hand rule, when a current carrying wire is placed perpendicularly inside the magnetic field, it experiences force, and due to the force, it rotates, and the force can be determined by using Fleming left-hand rule. So we have to write this. So current, I repeat, current flows from positive to the negative, and here is the magnetic field. So when the current carrying wire is placed perpendicularly inside the magnetic field, it experiences force. According to Fleming left-hand rule, the direction of the force can be determined. So when Fleming left-hand rule is applied, so the force at this end is downward and the force at this end is upward. So it rotates anti-clockwise. We have to write this in these lines. Next, the turning effect is increased when the coil is wound around the soft iron core. Explain why this happens. Actually, the soft iron increases the strength of the magnet. So this soft iron increases the strength of magnetism or magnet. So due to strong magnet, large force is experienced by the wire. Thus, turning effect, mean the torque, increases. So just one other way to increase the turning effect of the water. Increase the voltage supplied. You can write voltage. We have to write only one. So by increasing the voltage, we can increase the turning effect. And the second option is by increasing the number of turns of the coil. So more turns, more force experience, but we have to write only one, don't write two. Next, question number 8 is, the figure shows a potential divider circuit containing two resistors R1 and R2. There is an input voltage 6, and here is the output, mean output is across the R2. Complete the table to show the output voltage for the different values of the resistance of the two resistors. Both are of the same resistance, 8 and 8, mean the 6 volt is equally divided. Now, R1 is 800 and R2 is 1200. So either by using the ratio method, look, R1 ratio R2, 800 and 1200. So this is 2:3. So we have to answer the output voltage across R2. So R2 ratio is 3. So 3 out of 5 times 6. Or use the formula V1 is equal to R1 over R1 plus R2 into EMF. So the voltage required across the 1200 and the other is 800 and the EMF supplied is 6. So by both answers, by both method, we will calculate the answer, which is 3.6. Yes, 3.6 volt. And the next, in a circuit shown in the figure 8.1, the resistance R is replaced by the light dependent resistor. In the space below, draw a circuit symbol for the LDR, light dependent resistor. So this one, best. The LDR is moved from the darkness into the daylight. State what happens to the resistance of the LDR and the output voltage. So in the bright light, the resistance of the LDR decreases. When the resistance of the LDR decreases, mean here is the LDR, this is LDR, its voltage decreases, but the output voltage will increase. So the output voltage will increase. Next is, a potential divider circuit can also be used to produce an output voltage that changes with temperature. State the name of the component. Yes, thermistor. Resistance of the thermistor changes with temperature. Okay, so the next is optional. A simple bistable circuit contains NOR gates. In the space below, draw the circuit symbol of the NOR gate. So this is the symbol. So NOR. This is a symbol. And then describe what is meant by the bistable circuit. So it is an integrated circuit whose output has two stable states to which it is directed by the input signal. So this is actually the definition of this bistable circuit. And next, any two questions from this section, answer this. So I will attempt all, not two for you. So the question number 9 is, this figure represents the conversion of the energy in a mobile phone. State the form of energy stored in the battery. Definitely battery stores the chemical energy. And state the useful form of the output energy from the battery. Yes, we get the electric energy. State two usual form of the output energy from the mobile phone. Yes, picture, mean light plus sound. When the battery is in use, the average current is 1.3 milliampere. Milli mean 10 power minus 3. Determine the charge passing to the in time of 2 minutes. We have to write in second 2 times 60. So the formula is Q is equal to IT. The current is 1.3 into milli 10 power minus 3. And the time is 2 times 60. After calculation, this is coming 0.16 coulomb. And the next is, a student estimate the thermal energy produced in the battery when the mobile phone is used and uses this value to estimate the efficiency of the battery. He measures the temperature rise after 5 degrees. This is a change of temperature with the battery in a period of time when the useful energy output battery is 5200 joules. So this is the output. The mass of the battery is 110 gram and the specific heat capacity 830. Calculate the thermal energy needed to raise the temperature of the battery by 5 degrees Celsius. So formula, energy is equal to mc delta theta. So the mass in kg, 110 divided by 1000. Specific heat capacity is 830 and the change of temperature is 5. So this answer is coming 460 joule. Next, state what is meant by the efficiency. The efficiency is the ratio between output energy and input energy is called efficiency. Now calculate the efficiency. For the efficiency, two energies are required. One is given. Look, this is the output energy. It's mentioned here. So what is the input energy? So input energy is equal to lost plus output. This is the formula. Mean input energy, some is lost and the rest is output. So the first we will use the formula for the input. So loss is 460 and the output is 5200. So when we will calculate the efficiency, the output energy divided by input energy, the output energy is 5200 and the input energy is this is 5660. And after calculation, the answer is coming 0.92. So 0.92, it has no unit. If you want to write in percentage, you can write it 92%. So both answers are correct. State and explain one reason why the value of the efficiency calculated is larger than actual efficiency of the battery. Calculated in 3 is larger than the actual, mean this answer is bigger than actual. The reason is sum of energy, mean the heat energy, is lost in the surrounding, which is not mentioned here because we are just mentioning this energy which is absorbed by the mobile phone. The energy which is lost in the surrounding, which is absorbed by the surrounding, is not used here. So the actual answer is not this one. So due to the loss of the energy in the surrounding, the efficiency is smaller than this calculated value. Now, the question number 10. Figure shows a water wave moving from shallow into deep water. The wave fronts shown represent the crest of the wave. The water wave is made by dipping a wooden bar up and down the water. The bar makes 10 complete up and down movement in 5 seconds. Determine the wavelength in shallow water. So this is shallow water. So here we have to calculate this gap. So when you will calculate this gap in the actual hard copy, the answer will be 3.0 centimeter, I mean 3 centimeter. Now calculate the frequency. Frequency formula is the number of the waves divided by time taken. So how many waves are produced? 10 complete. And the time taken is 5. It's mentioned here. So the answer is 2 or 2.0 hertz. Determine the speed. So V is equal to F lambda. Our speed is equal to distance divided by time. So look, V is equal to F lambda. So the frequency is 2 and the wavelength is 3. So the answer is coming 6.0. This is centimeter per second because the wavelength is calculated in measured in centimeter. Next. On the figure 10.2, draw a line to show what happens to the wavelength, the frequency, and the speed of the wave as it enters the deep water. Frequency remains same. Wavelength increases. So speed decreases. Next. Direction of the boundary is now altered. The water wave now entered the deep water from the shallow water at the angle shown. Draw the wave front in the deep water. Okay, look, in deep water, the speed increases. So according to the refraction, when the speed increases, the wave bends away from the normal. So we will follow this rule. Suppose this is the line, incident. This is the normal. So it bends in this direction. So we have to draw a line like this. Okay. So you have to draw these lines like this. And keep this gap lambda greater than this one, okay? Next, white light is made up of the different colors. State the name of the 4 of the colors in the visible spectrum and place them in order from the smallest wavelength to the largest wavelength. So the white light has these colors. We have to write any one. The smallest wavelength, this violet. Then indigo. Then blue. Then green. So we have to write only 4, 1, 2, 3, 4, but you have to write in order, any 4 from these 7. Next, a narrow beam of the white light can be split into the different colors. State, this figure shows the ray of the white light emitted from the lamp. Complete the figure to show how the narrow beam is produced from these rays and how the spectrum is shown on the screen. Label your diagram. Okay, for this purpose, for the narrow beam, we will place a slit. This is a barrier. It has a hole. This is a slit. So the light rays are emerging from the slit. Okay, now question number 11. A highly radioactive source that emits beta particle is placed a few centimeters away from the detector. So this is the radioactive source. This is a detector, mean the GM counter. State the name of the particle which has the same mass and charge as beta particle. So beta particle is similar to electron. State and explain why the metal causing in the figure 11 is used. State and explain why the metal casing, this is actually used to prevent the exposure of the radiation in the surrounding, to avoid spreading of radiation in the surrounding. The casing is used. Next, state and explain what happens to the number of the particle detected in a minute as the radioactive source is moved. A few centimeters further away from the source. Few centimeters from the source. State and explain what happens to the number of the particles detected in the minute as the radioactive. Definitely, the beta particles reaching the GM tube will decrease. So definitely the number of particle reaching there, number of the particles will decrease. And the reason, because due to the distance, the particles, some of the particles will be stopped or are absorbed by the air. They will not reach the detector. Next, more than a meter away from the source. So more than a meter. So it means beta particle is completely absorbed by air because the range of the beta particle is 100 centimeter. So 100 centimeter, 1 meter. So it means no beta particle is reaching. So the detector will detect no beta particle because the beta particles are completely stopped by the 100 centimeter and they are absorbed completely by the air. The next is the nucleus of the strontium 90 decays by the beta emission to the nucleus yttrium. Complete the decay equation. So this beta has 0 because it has no mass number. Then this is 38. This is the after beta emission, this proton number increases. So this is 39 and the mass number remains same. So this is a complete equation. Nuclear fission and the fission both release large amount of energy. Describe how process of the nuclear fission different from the process of nuclear fission. In nuclear fission, heavy nucleus is broken into small nuclei along with the release of the energy. But in the fusion, 2 or more light nuclei are fused together to form a heavy nucleus along with the release of the energy. So this is the difference. So in fission, the nucleus is splitted into 2 or more light nuclei. But in fusion, the nucleus of 2 or more light nuclei are fused together to form a heavy nucleus. So totally different. Describe the condition needed for the nuclear fusion to take place. So it occurs at very high temperature because the nucleus are, all nuclei are the positively charged. So high temperature is required to overcome their repulsion. And this is naturally occurring at the surface of the sun because the high temperature is available there. So this is the paper.